the integration of dx over square root of e to the power 2x minus 1. For this one, we're going to use the U substitution. So I can say let u be equal to the square root of e 2x minus 1. Okay, this can be written as e 2x minus 1 to the power 1 over 2. Since we have a since we have a u here and we need to find our dx here, then we differentiate our u. So differentiating u, we get du is equals to, here we drop the power, 1 over 2 times 1, here we get 1 over 2, open, we write everything the way it is, so it will be e to the power 2x minus 1, then to the power, we subtract 1 from the power here, we get negative 1 over 2, so here it will be power 1 over 2. Then we multiply it by the differentiation of the inside function. When you differentiate the inside function, whenever you are differentiating e to the power 2x or e to the power something, you differentiate the power and multiply it by the whole function. So differentiation of 2x is simply 2, then you multiply it by e, meaning that the derivative of this is 2 e to the power 2x. That's how we differentiate this exponential function. So in this case, we're going to have 2 e to the power 2x here as the differentiation of the inside function. Then we have a dx. Simplifying this, we are going to have du, which will be equal to, since it has a negative power here, it's going to be on the denominator. Then since we have a 2 here, we can cancel out with this 2 here. So finally we're going to have e 2x dx over the square root of e 2x minus 1. But we had set to square root of e to the power 2x minus 1 equal to u. So here we can replace. So we're going to have du, which is equals to e 2x dx over u. So since we have this simplified version, we can now make our dx subject of formula. So it's going to be over 1. You multiply here, you are getting dx, which will be equal to u du over e 2x. So getting this function to and put it in the main integral, we're going to have on our dx we put this function, so it will be u du over e 2x, then everything over the square root of, since it's the square root of e to the power u, we can just replace it with u itself. So simplifying this, we're going to get u du over u e 2x. This u and this u will cancel out, meaning that what will remain will be du over e 2x. We can't integrate this one because we are trying to integrate this whole function with respect to u, and here we have an x. So to modify this, we are going to go back to the first part. We said u is equals to square root of e 2x minus 1. So we can square both sides, meaning we'll get u squared, which will be equal to e 2x minus 1. Making e 2x subject of formula, we're going to get u squared plus 1, which is equals to e 2x. So since we have e2x in terms of u, we can replace in our function. So we're going to have the integral of du over u squared plus 1. So to make it clear for some of us who can't read it, this is the same as the integral of 1 over u squared plus 1 du. Okay, so this, you will notice this, that is it's coming from the differentiation of tan inverse of u. Whenever you are differentiating arctan, you say the differentiation of u with respect to u is going to be 1 itself over 1 plus u squared. This is the standard form of the differentiation of arctan. Okay, the standard form for the differentiation of arctan. So since we have it here to say when you differentiate tan inverse of u, you get 1 over 1 plus u squared, meaning that when you integrate this same function is supposed to give you the arctan u. So here the integration of 1 over u squared plus 1 is simply tan arctan u plus c. But we said u is equals to square root of e 2x minus 2x minus 1. So replacing in this function, we're going to have tan inverse of square root of e 2x minus 1 plus c. This is our final function, answer.